Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about in the industry. It is of interest to determine the concentration of gases such as CO2, CO plus H2, O2 or others, either in the analysis of exhaust fumes from steam boilers to check their correct combustion, or in the analysis of concentration of gases from the point of view of safety in the event of an explosion, etc. Analyzers are generally based on characteristic properties of gases such as thermal conductivity, oxygen paramagnetism, and infrared absorption coefficient. A classic case of application of thermal conductivity principle is the determination of the carbon dioxide content of the combustion gases of a steam boiler. This determination is based on the difference thermal conductivity of this gas when comparing a cell with air or other possible constituents of the combustion gas. The gas is sucked in with a pump and passes into the cell. This contains a resistance wire electrically heated and maintained at a temperature slightly higher than that of the walls. With a good design and limiting the temperature rise of the hot wire, heat transmission by convection and radiation is negligible. Consequently, the resistance of the central wire is inversely proportional to the conductivity of the gas that surrounds it. Variations in gas and instrument temperature are compensated for by means of an identical closed thermal conductivity measurement cell containing air of known composition, or two sample cells and two reference cells. The measurement carried out in practice is the difference in resistance of the wires in contact with the air and with the combustion gas, respectively, and is carried out with a Wheatstone bridge circuit, which you can see on the screen. The system is used basically for air CO2 mixture, but it can also be used for other gases. Another example of the use of these analyzers is how to determine carbon monoxide and hydrogen in the combustion gases of the steam boiler. As these gases are combustible, they are burned with an excess of air, and the heat released is determined in a tube provided with an electrical heated wire whose resistance varies with the increase in temperature during combustion. The wire is connected to one branch of a Wheatstone bridge, and variations in outside temperature are compensated by inserting a similar but closed tube in the opposite branch. The result, expressed as a percentage of CO2 plus H2, is converted into an indicated or recorded signal. In another application, the oxygen content in combustion gases is determined by a variation in thermal conductivity when the gases are passed over carbon at high temperature, whereby all the oxygen present is converted to carbon dioxide. The instrument is similar to that used for CO2 determination, with a pair of thermal conductivity cells on each branch of a Wheatstone bridge. Combustion gases are passed through one pair, then through a small furnace containing high-temperature carbon rods, and finally through the other pair of cells. The change in thermal conductivity and consequently the increase in the proportion of CO2 is measured. The result can be indicated or recorded. Another complete apparatus that works on the principle of thermal conductivity is the chromatograph, which allows the components of a gas sample to be determined in a few minutes. It consists of a separation column for the gas components, a sampler, a controlled temperature chamber enclosing the detector, and a recorder that marks the peaks corresponding to the components on the graph. An exact quantity of gas to be analyzed is injected into the column, and it absorbs each of the components differently, in such a way that they advance at different speeds, arriving one after another at the conductivity detector that compares the thermal conductivities between the carrier gas and the mixture, giving a voltage proportional to the concentration of the corresponding gas. The area of each peak indicates the amount of each component in the mixture, and the retention time identifies the type of component. The chromatograph normally requires to be installed in a clean, air-conditioned room. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I upload videos every Wednesday in Spanish and every Friday in English. Adiós!